English. Okay, 1, 2. Okay, we'll do English. 2 is enough. So welcome everyone. It will be a talk about domain-driven design. It will be a talk about building really custom software for demanding clients. And it will be a talk about DDD in context of PHP and Symfony, but only a bit. So really all those rules you can apply to the software that you are building, and it doesn't matter which framework you use. It doesn't matter which technology you use, so you can do this in any technology, but it will be in the context of PHP, because I want to give you some examples how you can do that, so that maybe we will have a better idea how to build this software. So, few words about me in the beginning. So I'm from Poland. I'm from Cieszyn. If anyone is from Śląsk, that you should know where it's at. That's my Twitter handle. If you want to say something about this presentation, or if you want to talk about yesterday's workshops, because we did with Michał workshops yesterday. Also with Michał we founded a Prelegent PHP user group, which now is an event that is organized in many cities in Poland. So if you are from Wrocław, Warsaw, Gdańsk, or Silesia, you can attend PHPers meetups. I'm working as a software engineer at Sensio Labs UK, which is a part of Indica Group. So if you are interested also in the job, you can talk to me later. Also, I'm a Symfony certified developer. So if you have questions about Symfony, you can ask. That's enough about me. And I would like to start from this XKCD comics. So maybe you read it already, but what this comic is about, the guy, the business is coming and he's asking, hey, I need a software, and when user takes a photo, the app should check whether the user is in national park or not. And yeah, that's easy. You know how to do GPS lookup, how to check if it's a national park or not, so yeah, we can do that. And there is the next requirement. Okay, and I need to check whether on this photo that user just took, it's a photo of bird. And yeah, we need a couple of years and research team to do this. So for people from the outside, this difference is like they can't see the difference, because for them is equally abstract to localize user if he is in the national park and to localize bird on the picture. So the difference is really hard to explain for non-technical people, and it's basically the whole software building thing. Sometimes it's really hard to communicate. So that's the reason why domain-driven design was created, and the reason for that is that software is complex. The software really is complex, and things that we are building as developers are complex. Maybe they are not for us, but they are complex for the people from the outside, and building the right thing is complex. And to give you an example, that's the best example of complex software. One input and thousands of servers behind doing magic, right? So that's how software complex can be. So the question now is how to tackle it, how to build this software. And there are some approaches, and one of those is domain-driven design. And this is a term created by Eric Evans. And it's not like a strict methodology that you have to follow. It's not like a thing that you have to follow blindly. It's an approach, it's a set of rules and principles that you can follow if they work for you. It's also like a tool set, let's say, to have this conversation with client and to have an idea how to build your thing properly. And to do this, to build this thing properly, we need to focus on the core domain of our problem. So we need to focus on the problem that we are solving. And for example, that will be the example for this talk, that we'll be building some e-commerce website. So the domain of our problem will be shopping, doing some shopping. Will be a product catalog of catalogs that can be solved. So we need to focus on this problem because we need to solve it. We need to explore model of this software. We need to know what is inside, what objects are talking to each other, and how we map this real world to our objects, and that's the whole purpose of object-oriented programming, to model it somehow and to reflect it as good as we can. And we will explore this model with domain experts, with people that know what they are doing for, so with people that are working in such industry like e-commerce. And also we will explore this model with software experts that know how to build this software. And to explore that, there is a term, and it's called ubiquitous language. So this is the language that we are trying to work out to make sure we are on the same page with the business people, with the domain experts, and with software developers that are building this software. So all people knows, and when they talk exactly about the same thing. And we are talking about this thing in a bounded context. I'll explain it in a bit. But first, I want to tell you when to use DDD, because it's not like an approach, it's not like a Swiss Army knife to all the problems in this world. This is a complex approach, and we really need to implement it when we have a complex problem, complex domain. So let's say for us, blog domain. It's not a complex thing. We all know how blogs work, so we don't need to apply domain-driven design to it, because it doesn't make sense just to waste resources on it, right? So when we have a really complex problem, when I don't know, we are working with chemical industry, with I don't know some medicine experts, and we need to explore what they really need to do, what they need to implement. Then that's the reason why we could use DDD. And also when we have access to domain experts, to those people who work in this industry and can tell us, okay, this thing is modeled like this, and we call it such a thing. So, for example, in aviation, the distance, the fare that plane was doing from like Wrocław to London, let's say, it's called the leg. And it's not obvious for all of the people that are not working in industry, but for them it's like the most basic thing that planes or I don't know, containers are doing legs. So this is important to explore that and to know that they are talking about legs and what they mean by legs. Also, we need to have an iterative process in place. So it doesn't make sense to have a project with fixed scope, fixed time, just to say to deliver something, because we will be building something for weeks, months, and when we have iterative process like an agile in place, we can improve that and refactor our solution to reflect reality better. Not only to improve the code, but also to reflect this reality better. So the iterative process is important. And the last thing, we have to have strong object-oriented design skills. This domain-driven design approach is really all about writing really good OOD software. So that's one of the prerequisites for DDD. And we have two things, two sides of DDD. There is strategic DDD. You may wonder what's that. And so from the Greek, strategy comes from two words, which is stratos, which is, by the way, name in Greek, which is a really cool name. We are called army. That's her name. So that's leading the army. So in terms of DDD, strategy is about what we are doing, what is our problem, what we are trying to solve. And the strategic DDD is all about knowing what you are building in a bounded context. And you may wonder what's that. And example for bounded context is really easy. Imagine that you have a product, and what product means. Product has like a, let's say, name, it has a price, it has some attributes, it has images, it has reviews, and so on and so on. But really, this product means different thing for different people. So product is a different thing in context of catalog. This is just a set of values. But for sales, product is just a price. So that's a different context. And we shouldn't try to build all those contexts into one product. Also, it's a different thing for marketing, because they can they can use this product details in many different ways that we even could think about it. And for example, for warehouse, product is also a thing that has dimensions, and really what matter for them is that how big this product is and how they need to pack it and send it. So those are just contexts. And really building a software is building in one of those contexts, because you cannot do everything great and pack everything into one model, and it just doesn't work. We tried that, and we learned that trying to solve all the problems with one solution simply doesn't work. So we are building in one of those contexts. And if we need to build software that works in different contexts, we are just building slightly different software and trying to introduce, it's called anti-corruption layer, thing that know how to translate one object into another and they can work together. But this is like a more complex topic. So in order to know what product means in this bounded context, we all speak this ubiquitous language, which we'll explore with domain experts. And basically what it does, it connects these domain experts, these guys that know what their problem is about, with software experts. This like this connection between those two. And we'll focus only on the core domain. We won't apply all those principles, rules, patterns, and so on to the whole project. It just doesn't make sense. If you are building a shop and you want to focus on just the shopping domain, you won't apply all those rules, I don't know, to comments. It just doesn't make sense. This is a pretty standard thing, and you don't need to waste resources. You can just rely on things that are already built. You can buy them even. So you are focusing on your core problem, not on the supporting domains. So all these things around. And all this conversation should lead you to the model-driven design. So you are talking to the domain experts. You know that you need to model, let's say, a leg, and you know what leg means in terms of cargo. And what's really important for this whole process is the continuous integration. So you should really know that the whole software and solution works constantly, and we are improving this thing. So having things like Jenkins in place, like static code analysis and so on is really important. And testing is important. You maybe came across the testing pyramid. So really the foundation of our tests are unit tests. So if you are writing good decoupled software, you can easily write unit tests. You can have high coverage. I'm not saying you have to have 100%. You can just have a high coverage that you are comfortable with. Then on the top of it, just write some integration testing, but just a small bit, a couple of percent of your whole test suite, and on the very top, just some acceptance criteria. And the reason for that is you shouldn't really test things that are on the very bottom using your UI, because first thing, it's fragile. Second thing, it's really expensive in terms of resources, so it's time consuming, it's memory consuming, and it's hard to debug. And also, this layer should be just to prove to business that the solution that you are building works as intended. You shouldn't test all the edge cases and so on from the very top to the very bottom. And when we have tests in place, we can actually refactor. Because what refactoring is, it's improving the structure of your software without breaking it, without changing its behavior. So the only way to refactor effectively is to have tests that you can prove that you didn't change, you didn't break anything. If you are saying that you are doing refactoring without having tests, you are not refactoring, you are refactoring, with fuck. You are not sure that the thing you changed is still working, because you don't have proof of that. And also, refactoring towards deeper insight in domain-driven design means we are not only refactoring to improve the structure of the software in terms of design patterns and these kind of things, we are also refactoring to reflect our domain better. So if we learn that, I don't know, our product also has some dependency, and we can model this as a new object, and it will reflect the problem better, we can do this then. Because that's this kind of refactoring. So it's not refactoring from the technical point of view, it's from the mental point of view. So those are the strategic principles. Now it comes to tactics. And again, tactics from Greek, it's from tactica, the art of organizing an army. So these are the really low-level things that we can do in our software in order to support those ideas from strategic DD. So tactics is about how we build this software. And we have a whole set of building blocks. So basically, those building blocks in domain-driven design are all based on the layered architecture. So we are building our software starting from the domain, as I said. So we are modeling just our entities. We are modeling our sale, we are modeling our customer, we are modeling our product, and we know how those objects work. Then, on top of that, we are building our application. So we are designing how those objects interact between each other. When we know how they interact, we can decide on infrastructure, so things like database. It is a foundation, but on the very bottom and very low level. So we are not starting from the infrastructure, we are not starting from database, web services, and so on. We are building our domain first, and then just infrastructure is just an implementation detail. And on top of that, there will be a user interface that know how to interact with the user. It can be, I don't know, it can be a website, it can be a web app, whatever. And how those layers interact with each other. It's always from the bottom top. From the top to the bottom. So domains, of course, the domain relies on our infrastructure. So let's say, as we did yesterday on the workshops, we defined the task repository. We defined an interface here, and actually infrastructure had our implementation. So we implemented in memory. Then we were heading towards implementing it as a file repository, and then we could replace it with doctrine. So this is the thing that is on the bottom. We don't rely on it directly, but it is important. Then our application, our actual thing that we are building, relies on the domain. So it relies on our models and also relies on infrastructure because it has to. And on the very end, the actual user interface relies on domain and application. It doesn't rely on infrastructure directly. So it is a bit abstract, all that I'm talking about. But as an example of this shopping domain and Symfony project, I can tell you that we have our domain, and let's call it shopping here. So these are just our entities, our model. And then we are building a store called Amazon. So this is our store. Here is our Symfony bundle, which has a bit mixed responsibilities, but basically it's a bit infrastructure and also a bit of user interface. And then there is a doctrine adapter, which connects our whole thing to the database, which is a pure infrastructure thing. So this can be a simple structure for your layered architecture, layered architecture application in Symfony. So when we know where to put things, we need to know what we need to put in those folders. So basic thing, entities. We all know what entities are. So what's an entity? Entity is a thing that cannot be found and distinguished by its value. It just needs some identity, so some identifier. So a simple sale entity. So it's nothing complex, just a sale. It has some ID. We are constructed it somehow. It also has this get ID, so we can check if this sale, if you want to check if this sale and the other sale are the same, we are just comparing those IDs. So that's the first building block of the DDD in terms of objects. But also, this sale has a behavior. It's not an dynamic entity that just transfers data between database and the user. It also has some behavior. So when we call an activate method on our sale object, actually this method will check if the sale isn't already active. And if it's not, then activate it. So instead of having setters, set active doesn't mean nothing for user, but sale activate actually tells you something. It tells you the story, right? It tells you what the software does and why we want to do this. So that's entities. So entities have behavior. They're anemic. Then value objects. You may wonder what's value object. It's just a fancy wrapper for simple values. And a value object can be simple email. So you can build a really simple class like this, which in constructor gets a string, checks if it's an email. If it's not, it throws an exception. But if it is, then we are sure that we have a proper value object that is always valid. So if you are passing this email to some method, you don't need to check every single time if the string you pass is an email and it's valid to regex. You are just passing objects and you are 100% sure that it's okay, and you can rely on that. So this is such a simple concept, but it makes the whole programming thing a lot easier. Because basically you are just carrying through your functions this email and that's it, you don't care. And it simplifies things a lot. And the other example can be like geolocation can be a point which has a latitude, longitude. You can just pass the values and have this point as a value object. You don't have to pass an array and check those values in the floats, whatever. It's just a value that you need. So that's it. Another really simple thing, but it will model your domain. It will model the solution that you are building. Then the next thing that also has a cool name, but it's such simple concept. The aggregate is just an object that wraps another object, another entities inside. And that's it, really. So it's nothing complicated. It has a name, aggregate, in order to improve this communication. So when you are saying entity and when you are saying aggregate, these are really two big different things, but it's nothing really complicated. So if you are using object relational mapper, this aggregate will be mapped to some tables in database, but basically what you are interacting with is an order, and this order has a customer and has a product list, so it aggregates some other entities. That's the name for it. So cool. We know what are the first-class citizens of our solution. So now we need a place to fetch those things from. And again, talking about yesterday's workshops, those are repositories. So repository is a place that mediates between the domain and the infrastructure. So it knows how to save orders somewhere. For example, in database, but also it can be a file system, it can be API, whatever you need to use. But you don't rely on the actual implementation. You are just saving an order. You can remove an order from it. You can find by some ID. You can also have more specialized methods to find all obsolete orders or all non-paid orders. You can put those things on the repository if you need. And then you can implement it in whichever way you really want. So it's as easy. So the repository pattern is basically a collection of objects. It's not responsible for creating new objects, but it is responsible for saving and retrieving those objects. So for creating a new objects are responsible factories. So this is another design pattern. So if you need to create an object and it's complex to create it, you need to do a lot of things in order to create it. Just create a class that will do this for you. So let's say customer factory will have a method register with an email value object and password value object, do the whole magic that needs to be done, and then return the customer object. So it will set all the properties, create another entities if needed, but we don't need to care about it. Just encapsulate registering logic in some factory and use it. And when you look at it, it actually makes sense. We have a customer, a new coming customer that needs to register. So he's becoming like a registered customer. So even we can call it registered customer here, because we can have unregistered one. So when you actually read your code, it makes sense. It lets you understand what this code is about. And the services, another thing that we talked about, they are just classes that are doing something for you, but are not entities. So let's say you need to notify a user about something. It will be a service. So this is another fancy name for, let's say, utility class. And a simple service can be just notifier. So you need some notifier. It's an interface in this case. And you need to send a message to user. So this code again reads, notifier sends a message. That's it. And then we have a concrete implementation, which will be an email notifier, which sends a message using Swift transport. That's it. So services are again simple concept that make your domain express your intentions better. And to express those intentions even better, there are domain events. So inside your services, you can raise events. This is a simple implementation. So we need to, user wants to reset his password. So there is an email that identifies this user. So we are using our repository. So again, we are reading our code, and there is a user repository, and we want to find this user by email. Again, it's really easy. And then, if we didn't find this user, we are just raising new user does not exist event. And what this event means, we don't care. The implementation will be somewhere else. So some listener can send a flash message to the user that, okay, this email does not exist, maybe you want to register, or maybe it will send an email to this user, okay, you wanted to log in, you wanted to reset your password, but you don't have account, create a new one now. But if we have this user, we are requesting new password reset, and then saving this into another repository, and then raising another event, request issued event. So, and then react to it again. So we can, in a class that will listen to this event, we can log it to somewhere so that business can know how many requests are issued a month. We can display something to user. I don't know. We can automatically log in him after that. So just react and do something based on this event. So we talked about a lot of different classes, and what also is important, domain-driven design are modules, and they are not modules like in Drupal, but modules as a way of grouping things. So the things that we are talking about will be in the authentication module of the shopping. So there will be an exception, there will be a service that will reset password for us, there will be a request itself, and repository of this request. So when you go to your code again and open shopping authentication, you know what you can expect here. So it is important to group things properly and not have them cluttered around and hanging around and doing whatever they do. So there is a couple of different concepts that I discussed, and all this leads to a thing that's called supple design. And what we mean by supple design is to make the behavior obvious. So when you actually read your code, when you are reading your properties, your method calls, your function calls, it should be obvious what it does, and we should trust those methods. That when you are writing that the method will find this user by ID, it will find this method, but not, I don't know, register this method in underneath. So this is important to make the behavior obvious. And we can make it by intentionally revealing interfaces. So I already showed you how intentionally revealing interfaces look like. They are just describing the thing that the class is doing. And what is important, we are designing for change. The only thing that we can be sure about that our software will change in the future. And if you are not going to design your thing to change in the future, you will be stuck with spaghetti code, and eventually you will leave the company, and some other developers will be pissed about it because you did something wrong. So think about your software as a thing that will change, and make your software a thing that other developers want to work with. Make other people excited about your software. So when you are talking about your software and saying, okay, I've done this cool thing and that cool thing, So other people actually want to work on this project and don't want to leave the company. That's the whole point. We are building software that we will maintain for some time, and we really want to make sure that someone will work with this software, and we won't have a request to rewrite the whole thing in 2 months or something like this. So in order to do this, model your things first. Ignore things like database. If you model your entities, good tools, good frameworks, good libraries should support your model and map it to database somehow. You shouldn't really care about it. So database is secondary thing, the storage is secondary thing. You're modeling the reality, really, and database is not reality. It's all object-oriented software doesn't map good to the database. And what is also important, our domain model should be always in a valid state. And you may want to think, okay, we used validator in order to validate if our user is okay. But it's not really a good thing. If we have something, if we have product on the shelf in the store, we always know that this product is okay and we can go and buy it. And it shouldn't be a case that we're going to the store and we're checking if we can actually buy it, if the date is not expired or something like this. So what we can do this, how we can make sure that our objects are always in valid state, we can use a command pattern, which is again a really simple thing. So we want to change user's email. So we are just writing a command, change email command with email and customer ID. And then when we are handling this, we are finding customer ID, and not on customer, we are calling a method change email with some value object, let's say. So we are not setting new email, because what it means, we set new email. We are changing new email, and actually it means that some requested is changed. This is interaction that we are making with our software. And to make it even easier and express our intentions better, we can also use specification pattern, which is again a really simple thing. And the whole pattern is one simple interface, is satisfied by, and you can write a specification for a paying customer. So paying customer specification will have method is satisfied by that will check if our object is an instance of customer, and this customer spends some money. And then we can basically use that and check if our customer is paying and apply it to something and make use of it. So we have, let's say, free delivery calculator, and we paste any specification really that will work. We don't care what's the details of this specification, because we may want to turn this specification, this promotion on for some time and apply different rules. So we can just pass different specification. And then really, what we need to do is to call if this specification is satisfied with customer. So if it was paying customer, then we deliver for free. That's it. And now when you read this code, it actually tells you the story, what you are doing. There is some specification that is passed from the outside. We need to check that. But the responsibility of this class is applying this discount, not deciding whether user should get this discount or not. And the complex thing in domain-driven design is that sometimes we have to forget about model in some contexts. So when we work with our object and we are writing it, we want to save this object. It makes sense to have the whole aggregate, whole graph of the entities and save it, and use object relational mapper like Doctrine to make the persistence easier, to have the things like late loading and all the fancy stuff. And so those are the commands, those are the things that are writing our data down, are saving. And basically, as I said, we can use object relational mapper to do this. But then queries, actually fetching this data from database, doesn't need to use the same principles. We need to fetch our data and display our data in tables. We need to do this effectively, so lazy loading is not a thing for us, really. So we can just create some objects that will simply carry this data for us and fetch it from database. So you are writing simple SQL queries that will get the data with joins that you need that are performing really fast, and just displaying it using a bit different model. Because you cannot write a software model that will work both for edit operations and for read operations and all the other operations, and will satisfy all those things. In high scalable systems, it's basically not possible. Sometimes you can even denormalize the data and save your customers a database in order to edit it, but also save it to some other system, like Elasticsearch, to have your reads really fast and easy. And so for front end, it will be read from the different system, and that's really it. So the summary, the whole point of this domain-driven design will be to explore this domain knowledge. So explore the things that you need to build. Ask customer questions, why you need to build that. Because, I don't know, I want to contact this customer, or all the customers. Why you want to contact all these customers? Because I want to increase satisfaction. Why you want to increase satisfaction? Because finally, I want to increase sales by 10%. So that's the goal. Ask those questions and actually have these conversations, and maybe you can propose a better solution to the problem that client has. So instead of, I don't know, building this form, you can optimize something else and build something better just because you have conversation with the client and with these domain experts. And to speak that, to have this conversation, we need to speak this ubiquitous language. This is again a fancy name, but what this language means, basically, you are on the same page with those people and you are talking about the same things. And when you are talking about the same things, we can make use of those building blocks, of the entities, value object repositories, and so on, and apply really good object-oriented design, which is fun to build. And finally, what's the most important thing for me? Design for change. Design software that people want to work with, that want to extend, want to build Atom. It's really important. And for me, that's the only constant in the software, that we constantly have to build something new, have to extend it, have to change it. And to sum up all this talk, I will again quote the Eric Evans, the guy that created the domain-driven design. So in order to create a good software, you have to know what the software is about. And basically, that's my message for today, and thank you very much.
I have a first question.
Yeah.
In what layer, if we use MVC, in what layer you can implement this domain driving development, or do you advise to implement it everywhere, or for example in controller or something like that? This is something connected with?
Okay, so model view controller, it's not really a pattern that maps that easily to domain-driven design, because we can have things like controller will obviously go to the part of our application, right? But the model, so if you connect that, model is obviously the same thing, right? So we are building model in DDD, we are building model in MVC. There is just like the separation of this concern is stressed. So it's not like one-to-one mapping. These are a bit two different things in terms of MVC is really a programming pattern. DD is more like a mental pattern, how to build software, how to separate concerns in our software. Speak loud.
Okay, but you advise to use it everywhere, or?
Okay, I don't advise it to use it everywhere, and it's not it is a big investment. You won't build software as fast as with things like CRUD generators and so on, and you need to build things that are simple, that you know what you need to build, and you can use generators and you know how to build it, and it will support your business and make you earn money, then use it. I will advise it to use it when you have to build really complex things, As for example, my recent project that I was working on, it was for recruitment industry, let's say, and we had to build a really high scalable system. By high scalable, I mean like millions of emails a day, and we really had to think about performance of it and so on. So we spent months designing this model and building upon it. But basically, we had a client that really needed that, and that's one of the use cases. So for simple problems, I wouldn't advise it to use it.
Thank you.
There is a question in the back, I think. Yes? Or no? Sorry.
Does it work? Okay.
Yeah.
So it's not a question, it's only a comment. You said that always design your software for change.
Yeah.
And I fully agree. And I have advice that always design and document your software as developer who will take over your project is a psychopath who knows where you live.
Yeah, and what to secure you. Yeah, that's true. What I can advise if you want to read about it, I'm not saying just jump straight ahead and start doing domain-driven design because, well, it's hard, and you have to have people that know this stuff already because you will have many questions. So I advise to follow someone. But there are two books on the market, the two main books, and one is by Eric Evans, and it's called The Blue Book, and it's about 600 pages. It's quite hard. The other is the Red Book. So if you want to start reading about it and learning about it, start from the Blue Book. Okay, I think that's it. Thank you very much. About time, 42 minutes. Thank you.
Thank you.